Hello everyone, my name is Valerio Verso. I'm an associate professor for the Politecnico di Torino, Turin, Italy, and I'm going to be your teacher. I'm going to guide you through this exciting topic, the light outside buildings. We'll also have a participation from Giulio, Antonutto and Santiago Torres from Arup Lighting. They are going to present some interesting case studies to give and to show how the tools that I'm going to teach you and to share with you are actually used in practice. So let's get started. Well, the aim of this module wants to introduce the key terms and concepts about solar radiation and daylight at an urban scale. Two keywords, solar radiation and daylight. Solar radiation refers to the amount of radiation from a thermal viewpoint in terms of watt, particularly watt over square meters, which is called irradiance, whilst daylighting refers to the visual side of this solar radiation, a luminous flux hitting a surface, which is an illuminance. And I insist on this, both metrics are important, both analysis approaches are important, solar radiation and daylighting, because they are not independent of each other, they must be addressed together. And so that's what we're going to do also at an urban scale. So we also aim at introducing the difference between these two complementary analyses. The solar radiation on the one hand and urban daylighting on the other hand. Please note, solar radiation refers mainly to the energy, thermal and solar content of the solar radiation, and it is strongly related to this big issue called urban heat islands, UHIs, which is an important strategic topic nowadays from an urban viewpoint for urban planning to be considered as well, beside urban daylighting. Urban daylighting quantifies, refers to the amount of daylight which is available outside buildings. This is particularly important to predict, to understand the amount of solar radiation, the amount of urban daylighting outside the building, to later predict the amount of solar radiation and the amount of daylighting inside a building, which is crucial, of course, for both energy saving or energy consumption of building, and even more importantly, for the well-being, for the comfort, for the occupants. To this end, another aim is to provide, on the one hand, qualitative tools, such as the shading mask, on the other hand, quantitative tools, quantitative indexes, both to describe, complementarily, to describe and quantify daylighting and solar radiation on facades, roofs, parks, streets, any type of urban areas. Furthermore, we also are going to apply this concept to a room where we are going to calculate the luminance values, which of course are a consequence of the illuminance distribution, illuminance availability, the illuminance amount available outside. And we are going to provide some example and compare some situations for different urban settings. We'll understand how these different settings can result in a different daylight distribution inside a room, a reference room. It's going to be a classroom, particularly. What you could really expect out of this module, well, you will hopefully get a knowledge and a conscious understanding about solar radiation and daylighting at an urban scale. So urban heat islands on the one hand and urban daylighting on the other hand. Again, as a first step to quantify daylighting and solar radiation inside buildings at later design stages. So everything starts from the solar availability, the daylight availability outside the buildings. The second learning outcome is a knowledge on tools and metrics. Qualitative tools, shading mask, and quantitative indexes. For instance, just to anticipate a few names, a few terms, a few concepts, vertical sky component, solar beam angle. So we're going to focus on this in the next slides. This is the structure of the module. It contains three main parts, as you can see here. A submodule 1 will deal with solar radiation and urban heat islands, so on the solar and energy and thermal viewpoint. It's going to be shorter because the course is, of course, more intensively oriented to daylighting issues, but again, you cannot separate solar radiation and daylighting. You must address them together. So the second submodule, it's going to focus on urban daylighting. It's going to be longer, as you can see here. It will contain a number of capsules, one on direct sunlight, another one on diffuse skylight, which is the light reflected off the sky dome, shading mask, so qualitative tools to quantify the amount of solar radiation, and the metrics for urban daylight, both skylight and sunlight here involved. And this is your turn. Activity one activity is going to be an exercise for you, kind of self-assessment phase, and you'll calculate by yourself some illuminance values, illuminance distributions inside the reference room for different urban settings. Another application will be on the third part, so a number of case studies will be provided by Arup Lighting. So we're going to have two experts, two lighting designers working for Arup, Giulio Antonutto and Santiago Torres, who are going to present case studies from their professional activity. So this is going to be an application, very, very interesting part of this module to come to an end with this.